Now let's look at how to solve for unknowns with cylinders. So one thing I always want you to think about when you're solving these sorts of problems is make sure that the units are consistent. And what I mean by that is if you're using lengths that are all in centimeters, then make sure that your volume is in cubic centimeters or an area is in square centimeters. So a company's designing a 355 milliliter cylindrical sports drink bottle. If the surface area of the bottom is 40 square centimeters, how high does the bottle need to be? So we're being told about this cylindrical bottle. And from the information that we're given, let me get my sketch, there we go. Sorry, it's not a great cylinder. Let me try that a little better here. There we go, that's a little better. So we're told, looking at these values we're given, the area of the base. We're told that the area of the bottom of the cylinder, a base, is equal to 40 square centimeters. And we're also told that the volume, V, is equal to 355 milliliters. So you notice that my area of the base is square centimeters, my volume is milliliters. I have to make these agree, so I have to turn my 355 milliliters into cubic centimeters. Luckily, this is a really easy conversion because 1 milliliter is equal to 1 cubic centimeter, which means I'm just multiplying by 1 over 1, or it's no change. 1 cubic centimeter is equivalent to a milliliter. So this is 355 cubic centimeters. Now I'm ready to get going with the calculation. So the volume of a cylinder is the area of the base times the height. And look, I know both of those things and not the height. So I know the volume is 355 cubic centimeters. That's equal to the area of the base is 40 square centimeters times the height. So I'm just going to divide that 40 on each side to cancel it out on the right hand side. Leaves me with the height is equal to 355 divided by 40. That's 8 point, and I'm going to have to round to, let's say, 1 decimal place, 8.9 centimeters. Because all my volume and area measurements were in cubic centimeters and square centimeters, the length or height that I get out is going to be in centimeters. So let's do one more example. The cylinder below has a volume of 56 cubic centimeters. We want to find its radius. So we know the volume. Here's the volume. And it looks like from the diagram we also know the height is 4 centimeters. So I could write my equation out for the volume of a cylinder. Volume is area of the base times the height. Now that equation doesn't have the radius in it, but the radius is related to the area of the base, since that's the circle. So what I can do is I can go ahead and put in 56 cubic centimeters times the area of the base, is equal to the area of the base times the height is 4. So 56 is equal to the area of the base times 4. And I could divide away the 4 on each side, cancels out on the right, and I can calculate that the area of the base is equal to 56 divided by 4. That's 14 square centimeters. Now I also know, because the area of the base, or I should say that the base is a circle, the area of the base is pi r squared. So that means that if the area of the base is equal to pi r squared, I know that 14 is equal to pi r squared. And now I can solve this for r. So I'm going to divide each side by pi. So 14 divided by pi, that gets me 4.456 is equal to r squared. And now to solve for r, I have to just remove that square by taking the square root, and that leaves me with r is equal to the square root of 4.456. So the radius is 2 point, and again I'll round to 1 decimal place, 2.1 centimeters.